Welcome back to The Explainer. Today, we are tackling something absolutely crucial for every modern seafarer, protecting our fragile marine ecosystems from shipboard waste. If you operate a vessel, you know the stakes out there are incredibly high, both environmentally and legally. So today, we are looking at the ultimate solution designed to meet these rigorous demands head-on: the SEUNG ISS-25N Marine Sewage Treatment Plant. We're going to break down exactly how this system works, how to maintain it, and how to keep it running smoothly so you can protect our oceans with absolute confidence.
Okay, let's dive into this. We're going to trace the whole operator's journey today, starting with basic system specs and the treatment process, right through routine maintenance, essential spare parts, and finally some hands-on troubleshooting for when things break down.
Starting things off with Section 1, System Specifications and Purpose.
Before we get into the nuts and bolts, let's talk about the mission here, meeting those stringent MARPOL Annex 4 regulations. Now, take a look at this number, 1750. That is an impressive metric. The ISS-25N has a design capacity of 1,750 liters of sewage treatment every single day. To put that into perspective for you, assuming an average daily volume of 70 liters per person, this compact little plant effectively handles the daily blackwater load of up to 25 crew members on board. Not bad, right?
And the water coming out the other end isn't just visually clean, it is scientifically purified. The data brilliantly illustrates the rigorous standards the ISS-25N meets to ensure discharged water is environmentally safe. It crushes fecal coliform down to less than 100 mpn, slashes biochemical oxygen demand to under 25 milligrams per liter, and ensures the pH stays perfectly neutral between 6 and 8.5, literally the definition of environmental compliance.
Moving right along to Section 2, how the treatment works.
To really wrap our heads around this process, let's track a single, hypothetical drop of waste as it travels through the system's vital organs. Visually, you can see the overall flow moving from the sewage inlet on the far left, cascading through those internal chambers all the way to the discharge pump on the right. It is a super elegant biological and chemical sequence.
And that exact journey is broken down into 4 distinct stages. Our little drop of waste is going to travel sequentially through the biofilter reactor, drop down into the sedimentation tank, get polished up in the activated carbon tank, and finally be sanitized in the sterilization tank. Let's look closer at each step.
Okay, tank number 1, the biofilter reactor, using the fixed media method. Honestly, this is where the magic happens. The chamber is packed with media to give aerobic microorganisms a massive surface area to attach and thrive. They literally eat the organic waste. But here is the absolute key to the whole operation. An aeration blower is constantly pushing air through a diffuser to create these fine bubbles. Those bubbles deliver the oxygen that keeps our vital microscopic workers alive and hungry.
From there, our partially treated drop flows right into Stage 2, the sedimentation tank. This is just gravity doing its thing. The clearer, higher-grade water naturally rises and flows forward into the next tank, while any heavy, untreated sludge settles down at the bottom. But get this, it doesn't just sit there. The system actually loops that untreated sludge right back into the first biofilter tank so the microorganisms get another crack at breaking it down. It's a brilliant closed loop. So now, our much cleaner water enters Stage 3, the activated carbon tank. Think of this as your final physical and chemical polish. If any floating bits or funky odors manage to escape the sedimentation process, this activated carbon acts like a giant microscopic sponge. It filters and absorbs whatever chemical and biochemical oxygen demands are left, plus any lingering suspended solids.
Finally, we reach Stage 4, sterilization. The water is clean, but we need to make sure it's 100% safe. A chemical pump injects a very precise dose of disinfectant, specifically sodium hypochlorite, or NaOCl, right into the chamber. Once it's fully sterilized, a level sensor triggers the discharge pump, and that safe, treated water is automatically released overboard. And boom, journey complete.
All right, Section 3, routine maintenance guidelines. Let's talk about keeping this thing healthy.
You really want to think of maintenance as supporting the machine's immune system. And the absolutely crucial point here, the biggest takeaway, is that first bullet point. Never turn off the aeration blower outside of an absolute emergency. I mean it. Remember those hungry microorganisms we talked about in Tank 1? If you kill the air, they suffocate and die. If that happens, clarification efficiency plummets immediately. And it literally takes a full week for that bacteria colony to regrow. Aside from that, make sure your crew isn't throwing plastics or vinyl tissue down the toilet, use only easily biodegraded natural detergents, and do a hot water or steam back flush once a month.
Now, here is another number you've got to commit to memory: 3. That activated carbon in the third tank, it does amazing work, but it definitely has a finite lifespan. You absolutely must physically replace it every 3 years, no skipping.
Luckily, the replacement process itself is pretty straightforward. You're basically just removing the sludge, opening the cover, and pulling out the mesh that holds the old carbon. When you refill it, the manual is very specific. Only fill the mesh 2/3 full with the fresh carbon. Simple as that.
Next up, Section 4, Essential Spare Parts.
Look, to keep the system running, you need the right pieces on standby. Having this exact inventory from the ISS manual handy is literally the difference between a quick 10-minute fix and a massive marine pollution violation while you're stranded out at sea.
To summarize the absolute essentials here, you need to physically verify you've got these in your inventory: the mechanical seal and bearings for your discharge pump, bearings and oil seals for that critical aeration blower, a solid 20-liter supply of the NaOCl sterilizing chemical, and some basic electrical spares like lamp bulbs and 5-amp fuses for the main control panel. Seriously, double-check these before you ever set sail.
And finally, Section 5, Common Troubleshooting Solutions.
Because look, eventually something is going to act up. Picture this: you're down in the engine room, and suddenly the sewage plant drops pressure, or it won't suck in any air, or maybe it starts making this loud, alarming buzzing sound. Panic? Not a strategy.
Instead, we just turn to this elegantly structured troubleshooting matrix from the manual. It's laid out beautifully in an if X happens, then do Y format. It maps your exact symptoms straight to the root causes, and most importantly, gives you the actionable fixes.
Now, what's really interesting about this matrix is how fast and practical these solutions are. Motor making a buzzing noise? The impeller might be pressed. Just open the cover, check the gap, and replace parts if needed. Hearing a weird blooping sound? You've likely got high pressure or a dirty silencer, so you increase the pipe cross-section or clean the silencer. The matrix gives you instant, actionable fixes for basically every scenario, taking all the guesswork right out of it.
We've covered a ton of technical ground in this explainer today, from MARPOL specs and fixed media biofiltration, right through to carbon replacement and fixing buzzing impellers. But I want to leave you with this final provocative thought. If a single drop of poorly treated wastewater can disrupt an entire delicate marine ecosystem, are you absolutely certain your daily operational habits are helping the ISS-25N actually do its job? Remember those microscopic bacteria working tirelessly in Tank 1? Keep the air flowing, keep the bad chemicals out, and you will keep our oceans safe. Thanks for joining me on this explainer.